Okay, so 15.2 magnetic fields of electric currents. So you already know about this, but in a roundabout way. So if you think of the electromagnetic spectrum, that's your EM spectrum, so electric, magnetic. So you know that electricity and magnetism are linked because of this. So if you remember, you've got your gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, radio waves. Okay, you know that, and the diagram that you're used to seeing to represent that has this, where that's your wave, but that's only half the story. Okay, and this half of the story is telling you about either the electric part of the wave or the magnetic part of the wave, but not both. So the next thing you need to do is you need to look at it. So this one, like all waves that you know so far, it's moving up and down. Okay, like so, up and down, up and down, up and down. And that might be the electric part of it. Now it doesn't matter which is which, the key thing is how they are compared to each other, and that has to be at right angles to each other. So if I draw another wave at right angles to that first one that I've drawn, and this one is going up and down just the same, but the red one and the purple one, they're at right angles to each other, well, this one here, this one will be the magnetic. Now, and the way that this works is, as this purple one changes, this red one changes. So, and what that means for real life is that we can use the fact that electricity and magnetism are linked. So if we have an electric current, we can create a magnetic field, and if we've got a magnetic field, we can create an electric current. It's really, really handy. It's basically how all power stations work, how electromagnets work. You're pretty much getting onto how the modern world works here. Okay, and let's take that back now and let's simplify it, and let's talk about just one wire. Okay, so how does that relate to just one wire? So if I've got my simple circuit where I've got some form of battery, don't worry too much at the minute about which way the current is flowing from a battery. I'll explain that in a minute. Okay, so this is my wire, and it's going this way, like so. The way that I remember which one is the positive part of the battery and which one's the negative part of the battery is that if you have the big stick here, well, you can snap the big stick in two, and then you can put those two bits together to make a plus sign. So that one, the big one, is always the positive, because you can snap it in two, put them together, and make a plus sign. But you can't snap this one in two because it's already been snapped in two. Okay, and that's how you know that one's the positive. And then you know that the current will go from the positive to the negative. Okay, so next is something called the right hand grip rule. And what this is if you imagine that you then gripped hold of this wire with your right hand, okay, always with your right hand, and then you've got your thumb, okay, so you always grip it with your right hand. It doesn't matter whether it's that way or if it's that way, but you always grip it with your right hand. So let's draw a little diagram to show you. So this is me gripping the wire with my right hand, and if it's with my right hand and that's underneath of my hand, then my thumb has to be going that way. Okay, so if I'm holding onto a wire and that's my thumb, well then I know that the way that my fingers are curving round, the way that my fingers are going, so you see this way they're going and like that, that means that this one is going, means that the field lines are going that way. So the magnetic field is going this way. Okay, it goes with your fingers in the same direction as your fingers. Okay, so whichever direction your fingers are going in, so that way. So if I grip this pen, okay, what this tells me is that the current is going in here, out here, because that's in the direction of the thumb, and the magnetic field is going around this way in the same direction as my fingers. So I'll give that a bit more of an explanation now. Okay, so let's imagine that I grip hold of this wire that's in this diagram with my right hand. Okay, now I can see that the current, as shown by this arrow, is going round here. That would mean that my thumb would be going downwards. So if you imagine doing that, then you know your thumb is going downwards. Now if your thumb is going downwards when you grip hold of that wire, then your fingers have to be going round this way. Okay, which means that that would be the magnetic field would be going this way. Okay, and you know that this is true because if you put a compass in here and you put a compass on one of these, what you would find is, and remember if you go back to what we did in the first lesson on bar magnets, we know it always goes from north to south, which means that if I was to put in this, it means that this arrow here is going to go into a south pole and out of a north pole. Okay, which is very, very handy to know. So that would then go like that, and instead of pointing at the Earth's magnetic field, it would then start to line up pointing towards this one. Okay, so it would follow it round, and that's how you know which one it is. Okay, so you know that your fingers are going to be going round because your thumb's going to be pointing down. You know that means it's going to be going around this way in a clockwise direction, and that would mean that this one, wherever you put that compass, it is going to be following that line around. Okay, so that is the right hand grip rule. Now if I was to change the current the other way around, so if I was going to take my battery out and put it in the other way round, oops, so just put it in exactly the same way round. This time, okay, the current is going to be going upwards, which means that my thumb is going upwards, which means that this time my fingers are going around this way, which now means that it is good, that the magnetic field is going around that way, okay, in an anti-clockwise direction, and this time the compasses would line up going around the other way. Okay, so key things to remember are straight from this, the lines flow from north to south, always from north to south. Right hand grip rule just tells you if I know which way the current's going, will the magnetic field lines be going clockwise or anti-clockwise. So just grip it, whichever the thumb's going, that's the direction the current's going in, whichever way the fingers are going in, that's the direction that the magnetic field is going in, clockwise or anti-clockwise. Okay, so last bit is a special bit called a solenoid, and I'll start a new video for that.